Okay, so in lesson 2, we learned what the OCI and the CRI were and some of the ecosystem of the tools provided by those. In this lesson, we are going to now dig into one of those tools called Docker, and we're actually going to use it to pull and run an image. The Docker tool I have picked for this course because of its large compatibility on different OSs, as well as just how easy it is to use to do some of these tasks. Some of the other container runtimes, while they have reasons you might want to use them, they are also more difficult to do some of the more basic things. So, the very first thing we're going to do is we're going to learn how to pull our own image. So when I talk about image, a lot of people think VMs. I want to reiterate, and you're probably tired of me saying this already, but this image is not a full OS. It doesn't have its own kernel, and really it can have almost nothing in it. It is a bare base file system that has all of the requirements for your process. So if your process doesn't require anything, then it has nothing in it but your process. This is all that it really has, and there's a specific way to package it, and in the more advanced classes, we'll learn how to actually package that file system by hand ourselves. But today, we're just going to pull an image and run that image, and then maybe even interact with it a little bit. Later on in the very last lesson, we are going to learn about container registries, but just be known that Docker by default pulls images from the Docker Hub container images or container repository. So while you can store your own image there, and we will a little bit later on, this is where we're going to pull our Docker images from. So you know what? Let's just jump into the terminal and get this over with. So the very first command we're going to learn is Docker pull. Now we want to pull a pre-built Docker image. So let's do that. Go ahead and run Docker pull Docker samples 101 tutorial. This is all you need to do. And let's check and see if this container is actually there. So to do this, you can just run Docker images, and look, here we go. We have a Docker image of the same image that we just pulled. Now let's go ahead and run it. This is exciting. There's a very simple Docker run, and if you say Docker run and the image name, it's going to make a container based off of that image and run it. Cool, it worked. But this isn't quite what we wanted. We're kind of trapped inside this container that it's running, and we don't really want to do that. Let's start this in the background. To do that, you're going to just need to add the -d to run this in the background. So you run Docker run -d and then the image name, and now it's going to run it in the background. Whoa. Let's learn how to actually figure this stuff out on your own, so you don't need me to tell you every single command. Docker has all of its documentation in the command line. All you need to do is do the --help on whichever command you're trying to run. So if we do Docker run --help, you can see here that the -d and what it stands for. Now we understand more of what -d is doing. All right, so let's check out our container. We can run Docker ps to actually see what containers are actively running. And we can see that our container is running. But we notice there's an issue. This container has a web server served on port 80, but there's nothing running on port 80 on our local host. And this is because of the namespace isolation. It's running on a different namespace, a network namespace, than our PC. This isn't really that useful because now we can't actually see the container we started running. And while this might be the correct thing to do in a container orchestrator, a lot of times with local development, you actually want to interact with your container. So let's stop this container. Docker stop and then the container ID. Now this container ID is created for every single container that you run because you could run the same image multiple times. In fact, let's do that now. As you can see, I have 3 containers running, all of the same container name or container image. They all have a unique ID that I can reference uniquely and remove. How would I find this container ID that I'm talking about? Well, it's quite simple. All you have to do is run Docker ps and it's going to list the container IDs for you. Now, we have stopped our container, but we haven't actually deleted the container. The container still exists on the file system and it's just in a stopped state. You could actually restart this container if you wanted to. Now, how do you see the stopped containers? You add a --all to the ps command, and this is going to list out all the containers, even the stopped ones. How would you remove this container that's been stopped that we maybe don't even want anymore? To do that, you use the rm command and the container ID. So let's do that now. Docker rm and the container ID. It's now removed. And you can see that it's been completely removed from the file system. This is important because at a certain time, you're going to fill up a lot of storage space with containers that aren't even running anymore. And so it's kind of important to make sure you clean up after yourself. All right, so we have one last thing. We have pulled an image, we can run this image, but the last thing that we really want to do is we actually want to see this image mounted to our local host so that we can access it in our web browser. This isn't that hard because Docker actually gives us some tools to do this, and it is pretty easy. So we only need to add one single command to our command line, and that is the -p. And this p is going to let us proxy requests from a port on our PC, on our local host, to the container's namespace. So it's going to bridge the two namespaces and act as a proxy for us. So we can do the -p and add the p here. And you're going to see that we're going to do -p, and we're going to proxy from port 8080 on our PC, on my local host PC, to port 80 in the container where our web server is running. All right, so now let's check our local host and see if we have a web service running. All right, there you go. We have a container running and we are accessing it easily from our local machine. All right, this is fantastic. Now, if you're like, well, I want to do this with my own process, that's in the next lesson. Thank you for joining me, and I hope that you enjoyed this lesson, and please join me for the next lesson, and we'll learn how to build our own image with our own process.